So welcome everyone to our third session on lists and dictionaries. Today we have one of the warwick.ai researchers running the session, and he will be teaching you how to use lists and dictionaries to make more useful programs, and hopefully by the end of this course you'll be able to make your own simulation. So yeah, you can start, son.
All right. So I hope you guys have been enjoying the last few lessons and learning some new things in Python. So today we'll be going over lists and dictionaries. So far, I think in the first lesson, you've looked at variables. Now, variables are useful to store piece of data. However, the only issue is variables can only store one piece of data. For example, we can say number equals 4. So the variable number will store the value 4. However, let's say we want to store information about multiple pieces of data relating to one particular aspect. For example, let's say we want to store data about a shopping list. If we had 5 items in our shopping list, we would need 5 separate variables. Shopping list item 1 equals bread. Shopping list item 2 equals apples. That that's a bit inefficient. In Python, we can use a data structure called lists to store multiple pieces of data in one variable. And the way we define lists is we first have the variable name, the list name. So in this case, shopping list. We have an equal sign. And then this very important, we have 2 square brackets. And this declares an empty list variable. If we want to initialize our list with data, we we can populate it like this. So inside the square brackets, we have bread. So we're writing a string. So we have speech marks and then the item, in this case, bread. And then we separate it with a comma, and then we have our next item. Cheese, we separate it, and then we have our third item. So every item in a list is always separated by a comma. That's very important. The other thing is, lists are indexed. What that means is each item in a list has a location we refer to. So lists are zero index. What that means is the first index in a list we refer to as the zeroth index. The second item, in this case cheese, will be referred to as the first index. And so you can see the pattern here. Now, another advantage with lists is that we can have different data types in one list. So as you can see here, we have 2020, 2021, and 2023. These are all integer types. So whereas the rest, bread, cheese, and butter, are all strings. So another advantage with lists is that we can have different data types in one list. Thomas, I think there's a poll question,
Yeah,
item poll
so
question.
just to check your understanding of how you can declare a list, we have the small exercise. There are multiple options, and you have to select which lists are valid. So they're slightly different, and you might not have seen some of these examples, but give it a try and try to select the lists that you think are valid. And we'll give you a minute or so. This should be pretty quick. And then I'm gonna go through every example, and we'll see if they're all if which lists are valid and which aren't. So we know that they can have multiple types, and they can have multiple items. So there's a few examples on the poll. Some of them might be slightly misleading, but we'll see which ones are valid in a bit. Okay. We have, I think, 6 answers. I'm gonna wait a bit more. This is on the second link on the announcement. So if you open that, we're going to release questions there. This helps make the course more interactive. Okay. So all answers were valid. And so A, we have 5, which is an integer. We have cheese, which is a string. We have another integer. And we're also separating every item with a comma. So there's nothing wrong with this list. It's perfectly fine. I think most people selected this option. B, we have 3 strings. This is also valid. We have 3 items of the same type, and they're all separated by a comma again. Option C, we have a single item, and we don't need a comma if we only have an item, so you only need a comma when you're separating items. So in this case, this is also valid. But you could also have a single number inside with no comma, or a boolean inside, so you could have open bracket, true, and then close the brackets again. We have option D, where we have a string, we have 2 booleans and 2 numbers. This is also fine, because we know that lists can have items of different types inside. Option E looks slightly different from the other ones. We have 1 plus 1, 3 plus 3, and true. So 1 plus 1 will eventually just be simplified to 2 by Python. And so this is also fine. This is the same thing as storing number 2 on a list. For the second item, we have 3 plus 3. This is the same thing. So this is also valid. And we have a boolean at the end. And they're all separated by a comma, so we know that this list is valid. And finally, we have option F, where we have 2 booleans, so true and false. And for the second item, we have a nested list. And this is also fine because the list is just another type. And so all options were valid, even though some of them might seem slightly weird and not valid. So we're going to cover some operations now of how you can manipulate these lists to something useful.
Right. Thanks, Thomas. So we've looked now you're familiar with what lists are and what constitutes a valid list. Now we look at operations. So what can we do with lists? How can we change them? How can we extract information and so on? So the first operation we look at is the list index operation. So let's say we have our shopping list. We have bread, cheese, and butter. Let's say I want to print the first item, well, the item located in index 1, I want to print out. So I would say print the name of the list, square brackets, and then the location. So in this case, I'm referring to index 1. So if you look at the list, bread is at index 0, cheese is at index 1. So I should expect to see cheese. So if you run it, cheese. So if I wanted to print butter, then I would change this to 2, because butter is our third element, which is also in our second index. So if we put 2 there, butter gets printed. And for our first item, bread, we will need to put 0. Because remember, lists are always 0 indexed. So they start at 0. The next operation we look at is how to replace an element in a given location. So we have our shopping list, bread, cheese, and butter. Let's say I want to change butter to cream cheese. I first have the list name, shopping list, and then the location, to, which I want to change. I'm going to be changing butter. And then I equal that to the new item I want to replace. So if we run this, here we have the original list before we change the element. So that's printed out here. And then after we've added the new element in, changed the third element, we have cream cheese here, which you can see. Right.
Okay. So we have another exercise to check your understanding of what we just covered. And so we have a list, bread, cheese, and butter, and we're doing an operation, and I want you to select the option that has the correct output for that code. So we know that lists are zero indexed. So when we try to access the element at index 2, that's actually the third element. And finally, we're just printing the final list. You can only pick one option. There's only one correct option. And so I'll give you a few minutes to think about that. Okay, we have 6 answers. Should be hopefully straightforward. So we're assigning cream cheese to the second index on that list, and we're printing it afterwards. So it's very similar to what we just saw. Oops, sorry. So the answer is showing a C, but the answer should actually be option A. I'm not sure why this happened, but so we changed the third item to cream cheese, and so we replace butter with a new string, and then we print it, and this changes the list we have at the shopping list variable with cream cheese. So we'll now cover the append operation.
Thanks, Thomas. So we've looked at how to access values in a list and also how to reassign values in a list. Now we'll look at how to actually add values to a list. So to do that, we use the append function. So we create an empty shopping list with the square brackets. Then we have the list name dot append, and in our brackets we have the piece of data which we want to add to our shopping list. So if we run that, then we can see bread has been added. Bread has been added. Then if we want to add butter, let's say, we run the same append function again. So shopping list dot append butter, and that will add butter onto the existing list, which already contains bread. So butter will be added on as the second element. So butter is over here. Now the append function adds data to the end of a list. Let's say we want to add data to a specific location within the list. For that, we use the insert function. So similar to before, we've defined the shopping list, which contains bread and cheese. Let's say we want to insert butter in index location 1. Then we say shopping list dot insert the index which we want to insert it into, so index 1, and the piece of data we want to insert to it, so butter. So new order should be bread, butter, cheese, because butter has been inserted in the first index location. Now let's say we want to remove a piece of data from the list. For that, we use the remove function. So again, we've defined our shopping list. Let's say we want to remove bread. We do shopping list dot remove bread, the item we want to remove. And if we print that out, then you can see that bread has now been removed, and we're just left with cheese and butter. Now, as you can see, these two items now occupy the 0th and 1st index. So essentially, there is no there are no more 3 items. It's just cheese and butter. All right. Let's say we want to remove all items from the list. So empty. Then similar to before, we do shopping list dot clear, and this time we don't have to put anything inside the brackets. That should clear the whole array. So after we run it, we have this original list. And once we've cleared it, we're left with an empty list. Now, let's say we want to work out how long the list is. How many pieces of data does the list have? Then we can use the len function. So again, we've defined a shopping list. This time it contains 4 items. Let's say we want to print a statement saying how many items there are in the shopping list. We can formulate this statement: print there are, and we're adding len shopping list. So this will tell us how many items are in the shopping list. So if we run this,
Oh, we could see if anyone can spot the error. So, does anyone have any idea why this is not working? It's something to do with types, and we've seen this in the other sessions. So if anyone wants to explain how you would fix this, you can type in the chat or unmute your microphone. Yeah, so Funky Pigeon said we can use the string function on the length of the list. So we know that the length will be an integer number, and Python doesn't know how to add these two. So we need to change this to a string so we can join it with the other parts. If we run it now, we get the correct output. Thank you.
so yeah, thanks. So you can now see that there are 4 items in the list. So I think there's a item poll exercise for you to complete now.
Oh, it's after
Actually,
the dictionaries. Yeah.
oh yeah,
No
sorry.
worries.
So we've looked at lists as one data structure. Another data structure are dictionaries. Now dictionaries are the next step up in a sense. We, instead of using index locations, we use keys. So this is an example of a dictionary. Let's say we have a dictionary called contacts. We use curly brackets to define dictionaries. The first item always is what we call the key. So in this case, the keys are John, Alice, and Bob, and these are mapping to these values here. So John maps to John 2388. Alice maps to Alice 399, and so on. So if we want to retrieve the value at for the key John, then we can say print the dictionary name dot get and then the key we're referring to. So in this case, we're referring to John as the key. So this will print the value associated with John. So John 2 underscore 2388. So if we run that, you can see that is what is printed.
Okay.
So let's yeah.
So we have another exercise to check your understanding of dictionaries. In the example, we saw a list of contacts. So this could be maybe mapping names to a Snapchat username or Instagram. But you can actually use different data types as both keys and values. So similar to the list exercise, we have a few different examples, and you can also pick more than one option. And I want you to pick the dictionaries that are valid. So we have keys of different types, and we also have different values. And we know that a dictionary is always declared with the curly braces and separated with a comma. So if you can pick the options you think are the valid dictionaries, and then we will explain the answer. Gonna wait a bit more for any late answers. So again, all answers were valid. And starting with the first one, we have different types as keys, and this is fine. So this resembles how lists can have more than one data type stored inside. And for the first one, we have the number one, an integer mapping to a string, and then we have a string mapping to a string. And this is fine. You can have different types of keys and values as long as you're using the correct syntax. Skipping to part B, we have two strings mapping to other strings. So this is also fine. This is similar to the first example we saw. Even though we're using single quotes, that's also fine. That's another way of declaring a string. For the third one, we have true mapping to false and false mapping to true. So this is also fine. We have a boolean mapping to another boolean. Option D is a bit more confusing. And we have two keys that are John and Alice. And we know that they're strings because they're initialized with the single quotes. And as the value, we can actually have another dictionary. And this might be useful if you want to store more information for a given key instead of just a single string or something like that. So here we could have maybe an address book, and we also want to store the contact for a given name. And so we can map John to a new dictionary, and this dictionary has the address and the Instagram of that person. And we also have Alice mapping to her address and the contact. And finally, we have a similar example, but instead of having a nested dictionary, we have an array. And this is also valid. They're both just types we have in Python. So you can have them as values. And we have a shopping list. So all examples were valid dictionaries. And now we'll be covering different operations you can perform on dictionaries, so you can actually write something useful.
Right. So the first operation we'll look at is the .get method. So let's say we have again a dictionary of contacts. We want to get the value associated with John. So we say print contacts, so the name of our dictionary, .get, and then the name of the key. In this case, John. So if we run that, then we should get the value associated with John. If we wanted to get the value associated with Bob, then we can change this to Bob. And if we run that, then we get the value over here. Now, the same function can be carried out without the .get method. We could instead use the square brackets again to refer to the key. So it works in the same way the .get method works, but instead we don't have the .get and the brackets. We just have these square brackets. So it should perform the same thing. So there. Now we'll look at the key in dictionary function. So the key in dictionary function checks whether we have a specific key within our dictionary. So let's say we want to check whether a key called John actually existed within our dictionary. We can test it by doing this. So we can say print John in contacts. So this is the name of the key that we're checking. So we want to check whether John is in and then our dictionary name, contacts. So as you can see, John is in our contacts dictionary, therefore it will return true. However, if we run the same test with the key as Mike, Mike is clearly not in our contacts dictionary, therefore false will be returned. So now let's say we want to add a key and value to our dictionary. So here we have our contacts dictionary again, and there's only John, Alice, and Bob. But let's say we want to add Mike to our dictionary. We can have the dictionary name, the new key value, so in this case Mike, and then we have the actual value we want to associate with the key. So Mike underscore 00. So if we print out our contacts now after running it, we can see that we have the original three Alice, Bob, and John, but we also have an additional Mike, which has been added in. So I think there is now a item poll to
So
complete.
you can also use this syntax to update an existing key. So if we were to run the same code we have here, where instead of Mike, if we had John, and if we run this, we would update the existing key to a different value. And so if we run now, you can see that it changes the value of the existing key. And in this new question, we have an existing contacts dictionary with a single contact called Alice and mapping to Alice3 underscore 99, which is the contact. And we perform two operations and we print it. So I want you to pick the option which has the correct output after performing these operations on the first dictionary. We have two keys in the example, in the exercise, sorry. And it's Alice and warwick.ai. So based on what you've just learned, what do you think the output would be for this program? There's a single correct option, so you can select more than one. Okay, so I reveal the answer now. And the correct option was option D. And so firstly, option A, we have Alice mapping to the old value. And we also have Alice mapping to the new key. And the reason why this example is not valid is because in a dictionary, the keys must be unique. So the same key can only map to a single thing. So when we perform the first operation, we're actually updating the value of Alice. And so option A has two equal keys, and this is not possible in a dictionary, so this is not the correct output. In option B, we have unique keys, but the value hasn't changed for Alice. So in the first operation, we change it to Alice3 underscore 2021. And here we have the old value. So this is also not the correct output. Option C, we have again two equal keys. So Alice, Alice. And although we've updated the value, we know that we can have duplicated keys. So this is also not valid. And finally, option D, we have Alice mapping to our new value, which is Alice3 underscore 2021. And we also have the final operation, which is mapping warwick.ai to our website, warwick.ai. And so this is the correct option in this case.
Right. So now we've looked at how to a few operations to do with dictionaries. We'll look at the pop function. So the pop function, it does two things. It firstly removes the key and the corresponding value from the dictionary, but it also returns the value of the key back to the program. So let's have a look at an example. Again, we have our context dictionary, and now we're saying username. So we're defining a variable. Username equals context, our dictionary name, dot pop John. So we're doing two things here. We are removing John from our contacts dictionary, but we're also retrieving the value associated with John, and we're storing it within the username variable. So if we run this, we can see that John is no longer in the dictionary. However, username has taken the value of John, which was previously in the dictionary. So John's username is John2388. That is why statement worked. Right, so now we've looked at lists and dictionaries. Have a go at this exercise, trying to implement this problem. Trying to implement lists, trying to solve this problem. So using what we've learned, write a program which repeatedly prompts the user for items to be added to a shopping list. If the user enters X, we need to print the list of items and also the total number of items. So have a go at that for a few minutes.
There are also some comments on the notebook that should hopefully guide you a little bit when writing the code for this exercise. And this involves using things we've learned in the other lesson and also what we learned today. So the first step would be to choose the right data structure. And in this case, we're only storing a list of things. So a list would probably be ideal instead of a dictionary. And once you finish the exercise, if you can press finished on the item poll so you can have an idea of how many people finished it. And also if you have any questions, you can ask in the chat or unmute your microphone and ask here. Okay, I can see we have one answer. Does anyone have any questions about the exercise? Just as a reminder, we know that we can get input using the input function. And when we want to do something repeatedly, we learned how to do that in the last lesson with for and while loops. So you'd probably need to use those two features together to get the input from the user. And then also note that if the user enters the letter X, we want to print the shopping list. So you also need to do some type of comparison to check whether you should add the item or if you want to print the shopping list. Okay, I think maybe we can work through the solution now.
Okay, so let's have a look. Right, so the first step is to define our shopping list list. So shopping list equals square brackets, empty square brackets. So we are creating an empty list. Now, now I'm asking for an input. So item equals input, please enter your item. Now, so we want to repeatedly ask the user for an item. So we have to implement some sort of loop. Now we can choose between a for loop or a while loop. But to differentiate between the two, we need to check what are we actually considering. We want the user to enter the letter X to break the loop. So this is a condition control loop, in which case we have to use a while loop. So while item is not equal to X. So as long as the user doesn't enter the letter X, the program will keep asking the user to enter another item. If the user hasn't entered X, then we will be appending the item to our shopping list, and then we will be asking the user again for their next item. Now, to print the shopping list, we can use a for loop. So what we're doing here is for I in range 0 to len of shopping list. So what this does is it gives the variable I different values all the way from 0 to the length of the shopping list. So that will give values of I within the index range of our shopping list. So when I is 0, then item will be shopping list 0, which will be the first item in our shopping list. And therefore this loop will print out the items in our shopping list. Lastly, to print out the total number of items, we can use the len function. So print total number of items, len shopping list. So if we run this, so enter your item, bread, apples, oranges, and then let's say we want to stop the program asking for more. We enter X. Here we have our shopping list printed out. So bread, apples, oranges, and the total number of items as 3. Right. So let's move on now. Question 2. Exercise 2. Sorry.
Oh wait, so just
So
before we move on, does anyone have any questions about what we've done in this exercise? Okay, seems fine.
all right.
We can move on.
Okay. So exercise 2. So here we have data about a cell. So we want to write a function which gives a list of data of a given cell and prints it in the following format. So we want to print out cell ID as the ID given in the function, generation, location, energy, and sense distance. So this is our cell data, which is stored in a list. We want to print it out in this format. So have a go at this now. Think about how we're going to be able to access each of these items in the list, specifically to do with indexes and index locations.
Okay, so don't forget that we have the lists are ordered, and we have the order in which we have the things that we want to print. So we know that first we have an ID, and so this will be at index 0. And then we have a generation, which will be at the index 1. And so this is how we can get each information from the cell and print it. So does anyone have any questions about the exercise? And we have this function which will receive this array, this list, and then we want to print this information. And we know that you can do that with the print statement. We also know the indexes where we have the information that we want to print. So you need to put those things together to print the information from the cell. Okay, I think we can go through the solution now.
Okay. So we have our function, which takes in cell data as an array, as a list. And to print cell ID, we can refer to the 0th index of our cell data list. The 0 refers to the first location, so in this case it will print out 435. To print out our generation, we will refer to index location 1. To refer to location, as you can see in this example, location has two numbers, 5 and 6, which refers to the second and the third index location. So therefore we need two values, cell data 2 and cell data 3, in order to get the location of our cell. Energy will be in location 4 and sense distance will be in cell location 5. So if we run it, we get this output. Cell ID is 435, generation is 1, location is 2325, energy is 20, and sense direction is 5. Does anybody have any questions? All right, so let's move on then. So exercise 3 is to do with cell information. So if we have a list of data, so in this case, data referring to a cell, 4, 3, 5, 1, 23, 25, 20, and 5, it's not really structured. It's not really that useful to us. It doesn't tell us which one ID is, which one generation refers to, and so on. So it might be better to store it in a dictionary where we can actually use keys to refer to each of these values. So your next task is to use what you've learned about dictionaries so far to create your own dictionary for these values here. So think about the keys that you'll need to define and the values that each key will take.
So we have 5 different pieces of information that we want to store about this cell. And we also know that this information has a name, and we want to have a dictionary for each cell. So each cell would have a different dictionary with the same keys but different values because they might have a different state or a different location or energy. So you need to make a dictionary that has this information. So someone is asking if it's meant to have 6 values. Um, yeah, there's 6 values. So you have a cell ID, you have a generation, and the location is actually 2 values. So one is the x coordinate and the other is the y coordinate. Then you have the energy, census, and so on. Yeah, no worries. Okay, I think we can go to the solution now.
All right. So here we have defined our dictionary. So cell data improved. Our first key is cell ID, which is 435. Generation is 1. Now for location, you can put it as separate values. So location X, location Y, 2 different keys, or you can combine it into one key. So this data structure is called a tuple, which is just like a list. However, instead of square brackets, we use standard brackets. And the difference with tuples is that these cannot be changed. These are what we call immutable. They have fixed contents and a fixed size. So we can either define like that, this being the X and this being the Y location, or we can have 2 separate keys, location Y and location X. We have another key for energy and another key for sense distance. So if we print our new dictionary, this will be what gets printed out, which is our new and updated dictionary. So now that we've done this, we need to get. So here we have a dictionary, a list actually, which contains 3 dictionaries inside it. We want to complete this exercise so that it prints the information for the cells for the cells stored in the list. So here you can see we have information about 3 different cells. Each one has its own dictionary. We want to print the data referring to each one of these cells. So have a go at that. Now think about it. There are 3 different dictionaries inside here. So we're going to need to go through each one. We're going to have to iterate through each one. So we might have to use a loop.
So just a quick thing while we wait. The advantage of using a dictionary like this instead of the other array, the other list, is that it's much more readable to access the information this way than using the indexes. So if you have information and then 0, that's not very meaningful when you read the code the first time. And when you're working on a big project, you want other people to understand your code. And so if you use a dictionary, you have a much clearer way of showing the person that's reading your code what you're actually doing. So if we're accessing the ID of a cell, we would have maybe cell A and then get ID or gen. And this is much more readable. We can see that we're getting something about the cell that we have here instead of just some arbitrary number. So we want to print the information for all of these cells like we've done before. And we want to print them one after the other. So we already know that we need a loop of some kind. And then we need to get the individual information so that we can print it. And we know we can do that with the get method. So we might first print the ID, we have a generation, we have a location, and we have energy and sense distance. And this is a short piece of code from the simulation that you will build in this course, where we have a map with different cells, and they can move, they can sense food at a certain distance, and in this case that's the sense distance we have in the dictionary. And as they eat food they get more energy, and they can mutate, and new cells can appear in your simulation. And then if you run this multiple times you can see how it evolves over time. And this will be the main objective of this course. So I think we can get through the solution now.
Right. So the first step is to iterate through our dictionary. So for cell in cells, so cells is the name of our dictionary, and we're iterating through each cell. So in the first iteration, our variable cell will contain this dictionary. In the second iteration, our cell variable will contain this dictionary, and so on. So if we want to print the ID, we refer to our dictionary cell and the key ID. If we want to print the generation, then we refer to the cell and the generation key. If we want to print the location, then we need to refer to the location key. If we want to print the energy, we refer to the energy key, and for the sense distance, we will be referring to the sense distance key. So once we've written this and we run it, you can see that it first prints all the data referring to cell 1, then all the data referring to cell 2, and lastly all the data referring to cell 3. So does anybody have any questions?
I think we don't have any questions.
Alright.
Does anyone have any questions? You can type in the chat or speak here, either about this exercise or any.
I was just thinking about this dictionary in the context of the simulation. How could you explain how this might be useful for our final sim?
Sure. So we have multiple cells in our map in this simulation, and so if we use an array, we can store multiple cells instead of using separate variables. And we also need a quick way of accessing this information. So if we want to, for example, draw the map of our simulation, we need the coordinates of each cell. So we have the location key mapping to this tuple that has the x and y coordinates. And so when we reach that coordinate, we can display something that's different from the background. And we also have the energy key. So after a cell eats food, we can change this value accordingly to increase the energy of the cell. We also have sense distance. So when we create a new cell, with a given probability, the cell can increase its sense distance. And so with the dictionary, we have the information well organized, and we can change that to the new value. We can increment it to something.
Sure, but what if a cell dies or reproduces? What happens then? And then also, what if it eats? Say the location changes. What happens then?
What do you mean if it changes the location? Oh, I see.
So like say it's moving about, right? The location is not going to be fixed forever. It's going to change.
Oh, sure. So if the cell moves, we can change the location key. So we know that the tuple can't be changed. So we need to assign a new value to this location key. So we would create a new tuple with the new coordinates, and the other values would also be changed accordingly. So when the cell reproduces, it loses some energy. So we would have to modify the energy key by removing a certain amount from the total energy. And similarly in the generation key, so we know that each cell can reproduce, and the generation key represents how many cells were there before this one. So if we have Gen 3, we know that we had other three cells before. This is the third generation of this cell in, for example, a given family of cells. And we also have a unique ID so that we can identify the different cells in our map.
That makes sense. Thank you.
Yeah.
And thank you for the lesson.
Thank you.
So that was it for our lesson. I hope everyone enjoyed it. And I hope I'll see you next week.
Do we start working on the sim next week, or is that the week after?
I believe we start working on some parts of the simulation next week, yeah.
Cool. Nice one, guys. Thank you.
Oh, also,
Thank you.
we're gonna add your badges on Discord now. And once we finished adding them, we will ping you. And if you haven't got your badge and you attended the session, let us know and we can add the badge.